Hi everyone. Welcome to the video lesson for Monday and Tuesday. In case you missed class or you just want to review what we did in class. So today we started out with the warm-up. We started with the data from our lab about our unknown and tried to figure out what kind of bonding did that unknown substance have. Was it ionic, covalent, or metallic? So let's go to our graph. So I have our table from slide 10 or 11 from our part 2 notes for unit 4 to help us to figure out what kind of substance is our unknown. So my first piece of data was the smash test. So when I smashed it together, was it brittle and did it fall apart? Or was it malleable and did it take a new shape? Well, it was kind of smushed together, kind of took a new shape. So I'm going to say that it's a point away from it being ionic, a good case for it to not be ionic. It's a good possibility that it could make it a covalent compound, but metallic compounds are also pretty malleable. So I don't quite know who I am, and it is important to remember that these rules aren't super strong. They're kind of guidelines. So we need to do more than just one test to figure out what something is. So next was solid conductivity. My unknown did not conduct electricity as a solid. Well, ionic compounds don't conduct electricity as a solid. My covalent compounds do not conduct electricity as a solid. My metallic compounds are very conductive. They do conduct as a solid. So it's probably not a metallic for that reason. Let's keep going. My solubility was insoluble. Now, my ionic compounds in the lab, almost all of them dissolved. So, gosh, if all of my ionic compounds dissolved, this one does not. No, I think that's a point against ionic. My covalent compounds, well, most of my covalent compounds all dissolved really easily. But then the lauric acid did not dissolve very easily. So I don't think solubility is something I can really make a determination about whether or not it's covalent because my things seem to be soluble, but maybe sometimes insoluble. So I'm not going to give covalent a check or an X for this one. And then my metallic compounds were also insoluble. My metallic compounds, my copper and my zinc, they never dissolved. So that's 1 point towards metallic. Now, conductivity in water was not applicable. So first off, this is a good X against ionic because ionic was very conductive in water. My metallics also did not conduct electricity in water. However, for my metallic compound, and kind of for this one now, even if it is covalent, it did not dissolve in the water. My metals didn't dissolve in the water. So when I did my water conductivity test, I wasn't really testing a solution of my metal and the water. I was really only testing pure liquid water because pure water doesn't dissolve. Pure water does not conduct electricity. So that's why my metallic test in water was not conductive. I wasn't actually testing the metal. So my unknown also did not dissolve. So its conductivity test tells me that pure water does not conduct electricity, which we already know. So this doesn't really tell me too much about its actual conductivity in solution, since I didn't make a solution. And then my last thing is my melting point. My unknown was one of the fastest things to melt on that Bunsen burner flame. Well, my ionic compounds have very high boiling points and melting points, so it couldn't be ionic. And so do my metallic. So that's a point against them. And my covalent has very low melting points. So that's a point towards covalent. So all in all, it looks like my unknown was most likely a covalent compound. Now, remind me in class on Thursday and Friday, and I will tell you what that covalent compound was. But a few people did not quite get in their warm-up yet, so I want them to take a guess before I reveal what it was. So after the warm-up, we went over the agenda. We talked about our lab and then our POGIL homework. Now notice our POGIL homework is not to finish the POGIL. I only want you to go to page 4 of the Poggle, and we're going to circle back to that in just a moment. So in our lab, I know that some of these were a little bit hard to figure out what was going on, especially when it came to the smash test. It was a little bit hard for me to figure out what was going on, and I was actually there doing it. So I thought it would be a good idea to come back and talk about brittle versus malleable. So the sucrose, the sugar cubes broke apart when I smashed them with a mallet. So that makes them brittle. My lauric acid was kind of hard to judge. It wasn't really so much crystals as they were kind of flakes. And so when I smashed them with a mallet, they actually kind of smushed together more so than getting crushed. So I would actually say the lauric acid was maybe malleable. They smushed, so it makes it malleable. My citric acid, my calcium chloride, and my sodium chloride were all very brittle. I had small crystals, and when I hit them with a mallet, they became smaller crystals. And then my lauric acid, depending on your class period, I tried to talk about it at the end of class, but I was having some technical difficulties Thursday and Friday. The lauric acid would be somewhat soluble. It was somewhat insoluble, somewhat soluble. Some of it dissolved, but some of it did not dissolve as well. So it's somewhat soluble. So a little bit, it wasn't insoluble, but some of it did. And that brings me to the conductivity of my metals in water. So once again, I kind of mentioned this during the warm-up, but my metals did not dissolve in water. My copper strip and my zinc strip did not dissolve into the beaker. So when I tested their conductivity in solution, their conductivity in solution is 0. The reason for that is because I didn't make an actual solution. So its conductivity in solution is either 0, there's none, or it's not applicable. I can't actually test it since I can't actually make a solution of copper and water. And then lastly was the heating test. If I was able to melt it in the video with the Bunsen burner, that means it has a low melting point. I know some of those melting points were as high as the 400s. That's what the thermometer read. But as long as it melted, it's a low melting point. If I could not melt it, then it was a high melting point. So there's really no middle ground. It's either low, covalent compounds have low melting points, or it's ionic or metallic, and it has a very high melting point. It's one of those two extremes. Then after this, I threw you guys into that post-bond lab quiz. Remember, it is open note. You definitely need out this lab. Page 1 of the lab shows you on that periodic table who your metals, nonmetals, and metalloids are. So make sure you have that bonding lab open. Make sure you have this table open because a lot of questions come from this table. Also, make sure you have your Unit 4 notes, Part 2 open because that slide 10 or 11 is really useful. At this point, the second attempt has been unlocked for everyone. It no longer requires an access code to get into. So if you did not like your first score that you got in class, you can now reassess it. Of course, I strongly recommend that if you didn't like your test score for the first time around, please come and see me on Wednesday or come and see me Friday after school during that student support period, and I'll go through your answers and make sure you guys get the right ones, okay? I should note that I am pulling from a question bank, so you will not get the exact same questions both times. So after you were done with the quiz, your instructions were to start on the Poggle. So here in our modules, Lewis.structure Poggle, open up the PDF in the Cami, and you're only doing the first 4 pages. Now, most Poggles show you a pattern and it asks you what is the pattern. It asks you to explain why you think that pattern exists. This Poggle more explains what's going on, and it's going to have you practice it, have you demonstrate again what it just demonstrated for you. So it's a good bit of reading, and then it has you practice what it just told you about and what it just explained. So I want you to go through and finish up through page 4. All right. But hey, look, valence electrons, like that one worksheet we did, the Bohr model periodic table. that most important worksheet ever. In fact, in this worksheet, there are links to actually bring you right back here to the valence numbers so you don't have to memorize it. Although if you have your periodic table, then it's right there for you at all times too. So only go through to page 4. In class on Friday, we're going to go through these example problems, these rules for building Lewis dot structures, because it overlaps with our notes. So there's going to be time in class. I'm going to illustrate how to make these. I'm going to give you time to practice them. So please don't go beyond page 6 between now and our second class. Please stop yourself at page 4. If you really want to get ahead, you can go up to page 6, but please don't go any further than that because I want everyone to have time to practice in class on Friday. So that was our class on Monday and Tuesday. We took the quiz. Hopefully you had a good chance to get a head start on your POGL, only to page 4. And that is due at the beginning of class on Thursday and Friday. Otherwise, I hope everyone has a lovely Wednesday. I'll see you guys Thursday and Friday. Everyone stay safe, make good choices.